Welcome to today's lesson. I'll be talking about the mean, the variance, and the standard deviation. When I talk about standard deviation, it's a summary measure of the difference of each observation from the mean. We shall start with what we call the non-grouped data. When we are dealing with non-grouped data, to get the variance, the formula is we have the value of x's that we are given, that is the data given, which is x. So the first thing we do is to find the mean of x. That is the mean of that data given by adding all the data and divide by the number of items that they are. After finding that, we now get the mean. That is the data, that is x minus the mean, and then we square it. The sum of x minus the mean squared divided by the number of items will give you what we call the variance. And the standard deviation will be the square root of the variance. That is square root of the sum of x minus x mean squared over n will give you standard deviation. Example. Find the standard deviation of 4, 9, 11, 12, 17, 5, 8, 12, 14. So if you are asked to find the standard deviation in this case, like we have said, the first thing is to find the mean. The first thing is to find the mean. So what you do, you add all these numbers, that is to get the mean, we need to add all these numbers. We add all these numbers, that is 4 plus 9, 4 plus 9 plus 12, 11 plus 12 plus 17 plus 5 plus 8 plus 12 plus 14. All these we divide by how many they are. We count how many they are. They are 1, 2, 3, 4, 5, 6, 7, 8, 9. So we divide by 9. All these gives you what we call the mean. This will be 92. That will add up to 92 divided by 9. And that gives the mean as 10.22. As 10.22. Then from there, to make your work easier, you just make a table. You make a table of x. Then here we shall be having x minus the mean, that is minus x mean. Then here we shall be having x minus x mean squared. You make this table. Now when we start about x, now you rearrange all those numbers. You can arrange from smallest or just arrange them in whichever order, even the way they are, because it will not have an effect. Now that we are not finding either the median, they will not have an effect. Median, that's when you arrange from the smallest to biggest. So we shall have 4, 9, 11, 12, then we shall have 17, from 5, 8, 5, then 8, 5, 8, then 12 and 14. 12, then 14. Now, after having all these numbers, we subtract the mean from the x. That is 4 minus 10.22 will give you negative 6.22. Negative 6.22. 9 minus 10.22 gives you negative 1.22. Then 11 minus 10.22 gives you 0.78. 12 minus 10.22 gives you 1.78. This we shall get 1.78. Then next we shall get 6.78. Next we shall have negative 5.22. Next we shall have negative 2.22. Next we shall have 1.78. We had got it as 1.78. Next we shall have 3.78. Now these numbers that we have got, we square them. This first number 6.22 negative squared will give you that 8.69. We square the second one, gives you 1.49. 1.49. Next gives you 0.61. 0.61. Next gives you 3.17. Next gives you 45.97. Next gives you 27.25. 27.25. Next we shall have 7.25, so we shall have 4.93. Next we shall have 3.17. Next is 14.29. We need now to find the summation. We find the summation of this gives you, if you add all these numbers, it will give you 139.57. 139.57. So like we have learned from above, to get the variance, if you are asking about variance, to get the variance will be equal to summation of x minus mean, the value that you squared, that is sum, we divide by n. Now number of items, so which is equal to 139.57 divided by 9. 0.57 divided by 9. This gives the variance as 15.51. 15.51. Now, we need to get the standard deviation. Standard deviation is the square root of variance. It's the square root of variance, which is the summation of x minus the mean squared over n. So, which is equal to the square root of what we have found, which is 15.51. Square root of that, so it gives you the standard deviation to be 3.938. So this becomes our standard deviation. That is our standard deviation, and that's how we calculate the standard deviation of ungrouped data. You can find another scenario. Yes, you are dealing with ungrouped data, but you can find another scenario where you are asked to find the standard deviation. The data is ungrouped, but it has frequencies. If the data is ungrouped, but there are so many of them, that is, the frequencies are given and the data is ungrouped. Now we use a different approach because the number is so big. I mean, the frequency, there are so many of them. So we use a different approach. For us to find the standard deviation. So we want to deal with one case of that kind. When you find that the number are so many, and you're given like an example of such case. If you are given, like, you find the standard deviation of, now the data is given like x, and then you also have f, that is the frequencies of how many they are. So in this case, if you are given such a table, let me have it as vertical. So if you are given x, then you are given the frequency, a table like that. You are given, like, there is a number 0, there is a number 1, there is a number 2, there is a 3, a 4, there is under 5, and then you are given frequencies like the 0, those, if these were marks, those who scored 0 or 20. Then we also have this one 8, we have this one as 6, we have this one as 4, we have this one as 1, and this one as 1. So in this case, we need to have some more columns of fx so that we are able to find the mean fx. We need also to have fx squared. We need to have fx squared. So here, in this case, we approach it differently from the way we have approached the other one. Yes, the data is ungrouped, but there are so many of them. Each and every data has so many of them. Like if it is x 0, there were 20 of them. If it is 1 data, which is 1, then there were 8. So in this case, we have a different approach here. And like here, the one that was highest was 2. So the rest were just single datas. Now what we do here, for single datas, that is when you deal with the other approach. But when there are so many of them, you go with this approach. So we find fx and fx squared. So this becomes, fx becomes here 0. This becomes 8. This becomes 12. This is 12. This is 4. And this is 5. So we need to find the summation here. Summation gives of fx gives 41. You needed the summation here. Summation, if you add all this, you get it to be 40. Now we need to find fx squared. To get fx squared, already we have f and x. So whatever is squared is x. So the fx we have, we still multiply with the x to get fx squared. Because whatever is squared is x. So it is fx times x, which is 0. 8 times 1, which is 8. We need to have 12 times 2 gives you 24. 12 times 3 gives you 36. 4 times 4 gives you 16. 5 times 5 gives you 25. And then we need to find the sum. We need to find the sum, so we add all those numbers. If we add the sum here, is 25 plus 16 plus 36 plus 24 plus 8. So it gives 109. This is the sum. It is 109. Now, after finding the sum of your 109, for us to get the mean, if we are asked about the mean equals to summation of fx all over summation of f, which is equal to summation of fx is 41 divided by 40. So that means my mean here equals to 41 divided by 40 by using your calculator. 41 divided by 40, you get it to be 1.25. So that is your mean. Then you need to find the standard deviation. Standard deviation, we use now that formula that is equals to the square root of, that is summation of fx squared all over summation of f minus summation of fx all over summation of f, which is the mean. So the mean squared. So in this case, it will be equal to the square root. This one we get it to be 109 divided by our f is 40 some, then minus the mean squared, that's 1.025 squared. This gives you 109 divided by 40 gives you 2.725. Then we minus we minus, that is 1.025, we square, you'll get it to be 1.0506 square root. So when you subtract that, 2.725 minus 1.0506, you get 1.67, so it will be the square root of 1.6744. You find the square root of that gives you, that is the square root of the answer. It gives you 1.294. You write it to four significant figures, so it becomes 1.294. That is our standard deviation. So it is not for all cases that if you are given ungrouped data, you use the other formula. If those ungrouped data, they have frequencies, then that means you use the normal formula. But if there are no frequencies, they are just single data, we use that to get the deviation from the mean. We move ahead and now deal with an example when you are using what we call the assumed mean. Given the assumed mean, how do we find, and it's group data? That is, we want to work with group data. Under group data, we deal with two situations. We deal with given assumed mean and the one that you don't use assumed mean. We deal with two cases. One, you are using assumed mean, and the other one you don't use assumed mean, so that we see what you're supposed to do in those cases. That is will be our next example. That will be standard deviation for grouped data. Example 1, the table below shows masses. It shows masses to the nearest kg of number of people. That is the mass, and this is the frequencies. How many were they? 50 to 54, we had 19 people, that's the frequency. 55 to 59, 23. 60 to 64, 40. 65 to 69, 28. 70 to 74, 17. 75 to 79, 9. All that. What you do in this case, you first of all need to have a table. You write it in column form. So we shall have our mass, we call it we can call it a class, just mass as it is. We can't call it mass as it is. So we shall have the mass. We have the mass. Then we have what to call the frequency given. Then we also have what we call the x. X we find in the midpoints. Then we shall also have, you are given the assumed mean, so we shall have x minus 67, which is, we can call, give it a letter, like we give it a letter like D, so that we say D equals to x minus 67. That is our next column. Our next column is we can have FD. We can have FD. Now the frequency times the D. Then we can also have D squared. FD squared. Yes, after finding FD, we have FD squared. So we can have such. That's our table. Now the mass is 50 to 54, 50 to 54. It is 55 to 59. Next class, 55 to 59. Next class is 60 to 64. Next class is 65 to 69. Next class is 70 to 74. Next is 75 to 79. Next is 80 to 84. We have their frequencies. This one has a frequency of 4. If I go the reverse, 4, 9, 17, 28. Next is 40, 23, and then 19. You can find the sum of F here, sum of frequency. You add all of them, it gives you 140. Now X is 54 plus 50 divided by 2. We add 54 plus 50, we divide by 2. Then to get our X, it gives you 52. Next, 59 plus 55 divided by 2 gives you 57. Next is 60 plus 64 divided by 2 gives you 62. 62, this becomes 67. The midpoints, this becomes 72. You add the up and the that is the 2. This is 77. This becomes 82. Now we subtract X minus 67. 52 minus 67, you get is negative 15. 57 minus 67 gives you negative 10. 62 minus gives you negative 5. So we come here, gives you 0. Then here is 5, 10, 15. So we need FD. F this times this, FD. 19 times negative 15. FD, it gives you negative 285. Negative 285. This 23 times this is negative 230. Negative 230. 40 times this is negative 200. Negative 200. 28 times 0 is 0. 17 times 5 gives you 85. 85, then we shall have a 90 here and a 60 here. That's 60 here. Now you add the negatives numbers. This plus this gives you negative 715. You add these positives, they give you 235. So that means negative 715 plus 285. You'll find the summation of FD, summation of FD to be equal to negative 480. Get it to be negative 480. Then FD squared, remember you have FD. Then if I multiply by D, this and this gives me FD squared, because it is D that has been squared. So it is FD times D gives you FD squared. So we shall have negative 285 times negative 15, which gives you positive 4,275. That is 4275. Next will be 2300. Next will be 1000. That is 200 times 5 is 1000. Positive. Here we shall have a 0. 425. Next we shall have 900 and 900. We also need to find the sum. That is summation of FD squared. Summation of FD squared. You add all those numbers, they give you 9,800. Now, for us to find the mean, that is, you are using assumed mean, that is part A. To get the mean using assumed mean, the mean equals to 67, that is the assumed mean, 67 plus what we call summation of FD all over summation of F plus. So in simple terms, if we are, the formula is, it is the assumed mean, it is assumed mean plus summation of D, summation of D, summation of D all over summation of F. So if I use, which is equal to assumed mean is 67 plus summation of D is negative 480, all over negative 480 all over 140. That was our frequency summation. So this gives you as 67. This becomes negative minus 3.4286. If you subtract, you find your mean to be 59.57. 59.57 to four significant figures. So that becomes the mean. Now how do we find the standard deviation? Like we have said, that is part B. For us to find the standard deviation, we have seen from above that standard deviation, now here we say it is the square root, of course, of summation of FD squared all over summation of F minus summation of FD, that is the mean, summation of FD all over summation of F, the mean squared, like we said from above, is the mean squared. minus the mean squared. So it equals to 9800 all over 140 minus the mean we got 59.57. No, FD, not the mean, but the FD in this case. So if you confuse, you talk of the mean, you'll be wrong. It is the FD we got as negative 3. So it was negative 3.4286. It is FD all over F. We got this, we square it, then all these we find the square root. So this gives the square root of 58. If you do this one, it gives you 70. You minus, you square this is 11.725. 753, that is. You subtract, it gives you 58. So it is square root of 58.2447. 2447. So our standard deviation becomes 7.63. 7.6318 or 632. That is the two four significant figures. 632 because there is a 18, so you can write 632. That is the four significant figures. So that is how we find the standard deviation. That is how we find the standard deviation when you are given assumed mean. There is the other case. We talk about another case where you are not using assumed mean. If you are not using assumed mean, you just find the midpoint, that is x. You find fx and fx squared. So that we use now the mean squared. The mean squared, that is what we subtract on the under the square root. So that becomes the difference between the two. But generally, it is the same thing. It's only that assumed mean we have just simplified the work. Instead of doing very large numbers, we reduce them by using assumed mean. We try to reduce the numbers. So that is how we find using the assumed mean. So we deal with another example where we are not using assumed mean. That is our next example. We are not using assumed mean. Example 2, that is the following table shows the distribution of marks of 80 students. So 80 students, meaning the frequency must add up to 80. You calculate mean mark, and then you work out the standard deviation of the distribution. Now what we do here, we start with the mark. We have the mark, and then from the mark we write our next is the F. We need to find the X, that's the midpoint. Then we find Fx. Then we find Fx squared. Fx squared. So we start with 1 to 10. Next is 11 to 20. Next is 21 to 30. Next is 31 to 40. Next is 41 to 50. (51 to 60). Next is 61 to 70. Next is 71 to 80. Next is 81 to 90. Next is 91 to 100. Now the first one, it was one person who scored that, 6 people, and then we had 10 students here. Here there were 20. Here there were 15. Here there were 5. Here there were 14. Here there were 5. There were 3. And there was 1 student here. So we need to find the summation of f. If we find the sum here, it must give you 80. This one must give you 80 because you are told they were 80. So x is the midpoint. 10 plus 1, 11, 5.5. We divide by 2. Next is 20 plus 11 divided by 2, which gives you 15.5. Next should give you 25.5. Next is 35.5. We add the 2 and divided by 2 gives you 45.5. Gives you 55.5. Give you 65.5. Next gives you 75.5. Next is 85.5. Next is 95.5. Now we need to find fx. This times this. We start with 5.5. 15.5 times 6 gives you 93. Next is 255. Next is 710. Next is 682.5. Next, we multiply by 5 gives you 277.5. Next is 917. Next is 377.5. Next is 256.5. Next is 95.5. Now if you add all these fx, it gives you that is 3670. That is 670. Now fx squared, remember this fx is squared, so it is this times this, gives you fx squared, which is 30.25. Next is 1441.5. The only difference with this and the other one is that this gives you very large numbers. So we shall deal with 65 or 2.65 or 2.5, 25, 205. It gives 25, 205. Using your calculator, it is very simple work. That 1053, that 1053.75. That 1050.75. We have 1541, 401.25. The next is 60063, 60063.5. Next is 2854.25. 2854.25. Next is 21,930.75. And finally is 9120.25. So we need to have the sum of all these, gives you 199,000. If you add all these, gives you 199,250. As long as you have a calculator, it is not a big deal to do this. We could have reduced by dividing by numbers, but if you do that, you must be very keen when you are doing the calculations. But it's good to just write them direct because you have the calculator. Now what you do here after finding all these, so that means we can easily find the mean, which is equal to summation of fx all over summation of f, which is equal to fx gives you 3670. 3670 divided by 80, that is our mean, divided by 80. So our mean is 45.875. These were the marks. Those were the marks that's the mean mark. Then to get the standard deviation equals to square root of summation of f(x) squared all over summation of f minus summation of f x, that is now the mean, all over summation of f, the mean is squared, because we said the standard deviation is the deviation from the mean. So which is equal to the square root of 199,250 divided by 8, that is the mean, minus, now the mean, which is 45.875, we square it. So this gives you the square root of 2. This gives this one you divide, you get is 2490. 2490.625. Then we minus, you square the other and gives 2104. 2104, that is when you square the mean, 0.5156.5156. Now, which is equal to square root of 386. When you subtract, you get 386.1094. So this gives standard deviation as our standard deviation as 19. Square root of that gives you 19.6497 marks. The deviation was by that marks. This was the deviation from the mean, the standard deviation. So that is how you deal with a situation like that, where you are not finding, when you are not using the assumed mean. That is how you do it. So I hope that now you can do more practice by getting more questions from your course book, and then you do more examples of the same to see the differences on how to deal with standard deviation when you are given ungrouped data, that is non-grouped data that are just singles, and then you also have non-grouped data that are so many, whereby you are given the frequencies, and you also have group data. You are using assumed mean, that is, you simplify it, and also group data without using the assumed mean, how to find the standard deviation of all those. I hope that this one has been of help to you, and it's going to change your grade. Therefore, I ask you to subscribe to my channel, Mwalimu Ogeke, for more details on other subtopics and topics to come. Thank you for listening to me.